Hey everybody, Lars here. As you know, we're Python crazy this weekend, so it's time to do the second review video for Unit 5. And this video serves not only as an overview of two facets of object-oriented programming called inheritance and polymorphism, but in the very beginning you get to see another class and you get to review how we use classes and how we use them to instantiate objects, and then we use those objects in our programs to do the things we need to do. So let's get right to it. Rutgers is playing Penn State tonight, and I don't know, not mad, but disappointed that I can't be there, because I can't with my leg. I just can't. I can't walk around with crowds, and I can't do things like that. I am getting around in the boot, but it'd be dopey for me to try to do something like that. But within 15 minutes, my leg would be killing me, so it would be stupid. But hopefully in a couple of weeks, I will be able to do stuff. Enough of this. I digress. Let's take a look at this code that I already whipped up for us. I created a class called Animal, and what we'll do is we'll review it, and we'll run it, and then we're going to extend it, and then we're basically going to make it work not just for an animal, but for different, more specific animals like a cat, a dog, and things like that. All right, so let's just run the code. Run module, boom. As you can see, I ran it before. All right, and then let's run over what is going on here. As you're going to see as we move forward, we finally got to the point where what we're doing isn't going to fit on one screen anymore. So we're going to be going up and down, up and down, up and down. All right, let's review what's going on here. Bunch of comments, not run. A class definition, also not run. So we don't start running code till we get down here. We see our class animal. We see our constructor, dunder, init, dunder. Self, which is the name of the variable down here, as you know now. We take two variables, name and weight, and we set them equal to instance variables. Then we have a getter and a setter for the name. You can see the getter just returns the name. The setter takes a name and resets the variable for us. And the same thing with weight, get weight and set weight. So we have getters and setters for our two variables. And then we have one little definition down here, one little method called speak. And because animal is kind of generic, I don't know what the animal is going to sound like, so I just say print sound. This is going to come into play later in the video when we talk about polymorphism, but we will get there. Do not worry. All right? So, first thing we do, comment main. We don't run that. Here we go. I have a variable called A1, and I say with A1, I want to hold an object that you create with the animal class. And I want my animal to be called Fido, so I'm guessing I'm thinking dog. And I want Fido to be 35 pounds. So what happens here? I say, I want an object. Go use animal to make it. So I come up here and I say, do I have a class called animal? I do. Does it have a constructor? It does. Call the constructor, dunder init dunder, with self, which is A1, name, which is Fido, and weight, which is 35. So self.name is set to Fido. Self.weight is set to 35, and I now have an animal object with these two instance variables. Boom, done. I go to the next line, print, and then A1, get name. What is A1? It is an object created with the class animal. What is the method get name? I go to animal. Well, Python goes to animal and says init get name. Look at that, get name. It returns self.name. Self.name equals Fido. So I return the string Fido, which sits there. Then A1, what is A1? A1 is a variable that holds an object that was created with the animal class. Method, get weight. I go to that class. Is there a method called get weight? There is. What does it do? It returns self.weight. Self.weight, what is that? Self.weight was initialized when we first created the object, and it is 35. Okay, so this print is going to print Fido and then 35, which is exactly what it does. Okay, so that's a small review of a class. Now you've gotten your dice class, you've gotten your student record class. The last video we did, you got your bank account class. Now you're getting an animal class, but we're going to create a whole family of classes here. Because right now we're going to look at a facet of object orientation called inheritance. And it's one of the key components of object-oriented programming is this idea of code reuse. When I create a class, when I create something, I want to create it so that it can be used in more than one circumstance. So when I create this animal class, I create it kind of as a base for other classes to inherit from and use as I get more specific in my code. So let's say, for argument's sake, I want to create a cat. Okay? So instead of doing class cat, well, I am going to do class cat. Hold on. Let's say class cat. Okay? Here, let me give myself some room here so you guys can see. So, class cat, and then I would, basically come here and do my constructor, do my getters and setters, do my But I like what I see here in animal. I'm going to have, my cat's going to have a name, my cat's going to have a weight. I got getters and setters already written. Wouldn't it be nice if there was a way that I could just tell cat, hey, can we just go use all the stuff we did in animal? Right? Well, that's exactly what inheritance is. Basically, what we're going to do is we're going to tell cat to inherit from animal. So everything we do with cat, we can go back and use all of the things we've done in animal. Okay? But there's a trick. Basically, and what we're going to do it right now. First thing we're going to do, dunder init dunder, is we are going to define the constructor for cat. So what are we going to do? We're going to take the variables we took for the animal, but we're going to add one here too. We're going to add color. Okay? Here is the trick right here. I have self, name, weight, color, but I'm building on animal. So what do I want to do? I want to go build an animal object that I'm going to then add to. Think about Russian dolls. Think about Mr. Potato Head and having that base and then adding things to it. When I inherit from a class, I want to real quick go create an object of that thing and then bring it down to me, and then I'm going to build on top of it. So I actually want to call the constructor from the class I inherit from, and you'll learn as you get more involved with object orientation that the classes we inherit from, we usually call them the superclass. So what I'm basically going to do is I'm going to say animal. Now, we're not used to calling things this way, but basically, you see, look at that. It's giving me everything I can do with animal. We're going to say animal, and then we're going to call the constructor. Now, usually the constructor gets called automatically, but we're going to call it explicitly here. And I'm going to say self, which is weird because usually when we call things, we don't use self, but here we want to because we have a subclass going and calling the constructor of the superclass. And then I'm going to send it name. I'm going to send it weight. Okay? I'm not going to send it color because animal doesn't know what color is. Animal expects self, name, and weight. Okay? Boom. Now, because I have color, I'm just going to treat it like any other instance variable and say self.color equals color. Okay? And that's it. Okay? I went and got an animal object that cat is using, and then I defined color. Okay? So that's a little bit nuanced. You take a while, soak in that, get used to it. But basically, I'm calling the constructor of the parent class and saying, hey, give me an object real quick, and then I'm going to build on it, and that's how I'm going to do cat. Okay? Now, when I made my cat, I added a attribute. So I need getters and setters for that attribute. So I'm just going to say get color self return self.color and def set color. We haven't really used setters a lot because when I do the bank account, you don't really use setters, so you get to see them here. A setter is just a way to reset a variable. Real simple. Self.color equals color. Okay. Same thing we did in the constructor when we initialized it. We're just changing it. Okay. And then, because I'm going to talk about polymorphism later, I am going to go and write over speak. But what I'm going to do is I'm going to print meow. Okay? Look at this. Look how fast we built a whole new class. So, you can see that. Let me bring the code up here. So now we have a class, cat, which inherits from animal. So it can use get name, get weight, set weight, all of those things. And you can also use getters and setters for the color of the animal. And now it has its very own speak method that says meow. Okay? So let's use it. It's going to be more understandable if we use it. Should I keep the nah, it's just going to convolute things. I'm going to have a variable now called C1, and I'm going to say make it equal to cat. And I'm going to say cat's name is Felix, weight is 15 pounds. We don't want a fat cat, and I will make Felix orange. Okay? Then, why did that not just go to the next line? Why did that go down there? What am I doing wrong? Well, you know what? I will, like everything else, I'll find out. Then I am going to print C1.getName, C1.getWeight, C1.getColor. And then on its very own separate line, that's going to blow up somehow, and I'm going to find out why. What is it? Well, we'll find out. I'm going to run C1.speak because it prints it out itself, and I don't need to do that. Okay? Now, I'm going to run this code. Hopefully it runs, although I think something's going to break. Something's wrong with the syntax here. Let's see. Feelings. Oh, you know what? You know what? It shouldn't care. I'm mixing and matching my delimiters there for my strings. That might have something to do with that. They were balanced in there. All right, well, we're going to find out. All right, we're going to get a cat object, and I'm going to trace through this after we run it. So let's just run the thing and see what we get. Ta-da! End of line while scanning. There's my prowl. All right, so now we got that figured out. And now, get color is not defined. Is something misspelled here? C1 dot get color. Yay. So, when did that come up? All right, Felix 15, orange, and then meow. So, let's trace through this code. As you know, comments, class animal, class cat gets put in memory. Main is a comment. The first time we really do anything is I have the variable C1, and I make it equal to, I want to get an object, and that object is created using the class cat. And then I give it a string Felix, an integer 15, and a string orange. So, cat. Does class cat exist? It does. I want to run its constructor, self, which is C1. Name, Felix, weight, 15, color, orange. We're in good shape. Animal, dot init. I want to go run the constructor of the parent class. What is animal? Do I inherit from something? I do. Look at that. Cat inherits from animal. So let's go up and look for animal. I find animal. I run the constructor. Self, C1. Name, Felix, weight, 15. So what do? I create an animal object. It contains two instance variables, name, Felix, weight, 15. And that gets brought back down here. Okay? Now I define self.color as orange, and I'm ready to rock and roll. Okay? I have an object, cat, with three instance variables. The name, the weight, and the color. So then, I return back here to the main call, and C1 points to my object. So now, print C1, get name. What is C1? C1 is a variable that holds an object that was created with cat. So I go to cat. Is there a method called get name? And it, get color, set color, speak. No, there isn't. But we're going to get out of Dodge, because then Python says, okay, did cat inherit from something? It did. It inherited from animal. So now we're going to go back up to animal. Is there a method called getName? Init. GetName? Yes, there is. And what does it do? It returns self.name. Self.name was defined up here when we ran the animal constructor. And what does it contain? The string Felix. So when we run this, we're going to get the string Felix. C1.getWeight, same story. C1 is a variable that holds an object that was created with a cat class. I go to the cat class. Is there a getWeight? Blip, 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 blip. No, there is not. But I look up here and I see that my class inherited from animal. So I go up to animal. Is there getWeight? Init, blip, blip, blip. Yes, there is. GetWeight. Return self.weight. Self.weight was defined up here in the constructor. It equals 15. So I'm going to print 15 here. Now, a little bit different. C1, what is it? It's a variable, points to an object. That object was created with the cat class. I go to the cat class. Get color, does it exist? Get color. Yes, it does. So I found it in my cat class. I'm going to return self.color. Self.color was defined right here in the cat constructor, and it returns the string orange. So I'm going to get Felix, I'm going to get 15, and I'm going to get orange. And what happens? Exactly that. Felix, 15, and orange right here. Okay? So now hopefully as you're watching this go through, you're getting a little bit of flavor for what, inheritance is all about. Now we're going to touch upon polymorphism. And polymorphism is a weird sounding word, but if you break it down, just think of poly means many, and morph, could mean change, but it could also mean form. And that's the context in which we use it in computer science. We think of polymorphism as many forms. And what we've done here is I say C1.speak. And what is C1? C1 is a variable that holds an object that was created with a cat class. So I go up to cat. Is there a method called speak? Yes, there is. So I run it. Print meow. Meow. Boom. But if that didn't exist and I said C1.speak, let's show you. It says sound. Okay? Why does it say sound? C1.speak. C1 is a variable that holds an object that was created with a cat class. Cat class. Does speak exist? 1, 2, 3. No, it doesn't. Commented out. But I inherit from animal. So let's go up to animal. Does speak exist? Yes, it does. Look at that. So I print sound, and that's what happens. Okay? But what you notice, and what's different from when we did what the hell happened there? So what's different from when we did our getters and setters and stuff like that is both of these methods have the same name. And you might be thinking, well, cat inherits from animal. Why don't we just go rewrite animal and make animal say meow? Or why don't we do something like that? Well, we can't really do that because animal might be used by other things. Animal's kind of generic. Back in the day, something like animal would be called an abstract class, where we don't really want to instantiate it. We want it to sit there and be used or inherited by other classes as what's called a base class. So, but in our case, we really don't want to rewrite it. What we want to do is what's called override it, or create one for ourselves so that when it's called, we definitely use that one instead of going that. Because I know my cat says meow. When I do a dog class, my dog's going to say woof or bark, So I want to write over it. So that's basically what polymorphism is about. Things can have the same name, but depending on their context or what object is using them, they have different behaviors. Okay? So if I have a class and I say speak for a certain animal, it's going to act that way because it's that class. If I say speak on my dog, it's going to say bark. If I say speak on my cow, it's going to say moo. It's going to do different things based on the context. And I can do that in Python by writing a speak method for every different class I have. And you will always default to the one in your class like we did with cat right here, and you'll always say meow. Okay? It doesn't really get more complicated than that. You'll learn more in the next video about the difference between two different things called overriding and overloading. Overloading, Python doesn't really support, but polymorphism has to do with overloading too, because what overloading is that you can have a method with the same name defined differently by the amount of arguments you give it. If you take the name of a function plus its arguments, that's usually called its signature. And you can have different signatures in different object-oriented languages, Java, C++. In Python, we don't really support that. We don't really support overloading. Although, you can, forget what I was about to say. I was going to bring up the topic of operator overloading, but we don't want to get that complicated. So don't worry about that nonsense. Basically, we handle polymorphic behavior in classes in a Python context with overriding things and just making sure that we, have our house and things in order when we do polymorphic stuff, like a speak method for a class for an animal, okay? So it doesn't get more complicated than that. You're not going to get some long chain convoluted example in a quiz, or you're not going to be asked to do something super complicated as far as polymorphism is concerned, all right? I want you to understand the basics of it. Object-oriented programming, there's big topics to cover. One is the general idea of classes and creating blueprints and then getting objects by using that blueprint and then using these objects to complete our tasks. That's the big overall idea. Then there's an idea which we completely skip over called encapsulation, and that is private data, public data, different things along those lines. If you know C++ and Java, you're probably saying to yourself, where is the encapsulation stuff, blah, blah, blah. I completely skip over that because what you learn very quickly when you become a professional programmer is that a lot of other programmers are ignoring that too, and they just make everything public. Maybe it's not the best way to write code all the time, but a lot of times everything is available to everything else. There are ways to hide data from other modules and do things. There's private, there's public, there's protected if you're a C++ programmer. So there's different ways to deal with hiding things from other things. I don't bother with that. Like I said, I got a lot of stuff to teach you, and I got 15 weeks to do it. So I got to make choices. One of the choices I make is that encapsulation kind of goes, but I wanted to mention it. Okay, because like I say, it's all exposure. I want to make mention to you. I want you to know about these things. That way, if another programmer brings up encapsulation, at least you've heard the term. You can go look at Wikipedia now or Google it, and you can get smart. The two things I do want to go over and show you are inheritance and polymorphism, and you've gotten them in this one. You understand now inheritance. Inheritance is when I've got a class, and I want to go use another class that's already been written. Code reuse makes sense in a logical order. I can build a hierarchy of classes that all build up on other ones, and boom, boom, boom. You would see that I could now write a class that inherited cat. And when I inherit cat, I'm really bringing along animal for the ride as well, because cat inherits from animal. So you're building hierarchies. You're building chains that go up and down and use these different classes. Okay? And polymorphism, like you said, is just different forms. It's if I write a method for one object and I write another method for another, and they do similar tasks like speaking or running or doing things. Well, those two different things, depending on their context, are going to do things differently. I can write two different methods and give it the same name. As you can see, animal has a speak method that prints sound. Cat has a speak method that prints meow. Same thing, but we make it work. That's basically many forms or polymorphism, okay? Polymorphism also deals with, you know, different signatures and being able to write methods that have different signatures and do different things, but Python doesn't support overloading. We do overloading in a different way in Python. Don't let that make your brain hurt, all right? All right, then that's basically where I'm going to stop as far as this video is concerned. The last video for this unit is basically some neat features and some cleanup stuff, okay? We're going to go over these things called class variables you've seen so far. Self.name, self.weight, self.color, what are called instance variables. When I create an object, my object has all of those variables all to itself. And those are the variables that are for just that object. Well, there's another kind of variable. I was going to say class of variable, but that wouldn't convolute terms too much, would it? There's another kind of variable called a class variable, where you can set up a variable and every object created with that class can access those variables, which is a neat thing to use. It's very useful with like scoreboards and stuff if you do game programming and stuff like that. We're also going to review the polar opposite of the constructor, his evil twin called the deconstructor. And we're going to learn how to delete objects, and we're going to learn that we can set up a method to run when we delete objects, and it's called the deconstructor. And then we're going to discuss some of the stuff we were just discussing 3 minutes ago with overriding versus overloading and stuff like that. And then we're going to set up one big final program where I'm going to show you that classes can go into libraries just like functions can. So we can take all of these things and we can go stick them in a library, our own library, and basically just import classes the way we import functions and the way we import from libraries. Okay? So we're going to do all that stuff in video 3. This is video 2. Watch it, absorb it, learn it, love it, live it, and we are going to move forward. All right, announcements. I mean, it's Saturday. It's my crazy weekend of Python. I did not watch as much Blacklist last night as I wanted to, although I was up late. I was up until like 4 in the morning, but I'm shot today. Today's the day where everything caught up to me, and I was super exhausted, so I slept until like noon, and then I just putzed around the house. Caught a mouse. I don't know. I shot a little bit of video on my phone. Maybe I'll put it up later. I'm big on. It's a long story, but I used to smoke a pipe. I don't anymore. I quit on New Year's Day. It was a New Year's resolution. So it's been 10 months, and I haven't smoked a pipe. But what helped me quit smoking the pipe was sunflower seeds. For whatever reason, I would go out and get David sunflower seeds. I like the ranch. And I would just, like when you're a kid and you're playing baseball, you just put some sunflower seeds in your mouth and you take the shells off and you eat the seed, boom, and you spit it in the cup. And these things were very helpful as far as me quitting smoking. And what happens is I take these sunflower seeds and I leave them all over the house. So I left one in my bookcase, and a mouse crawled in and got caught. And all of a sudden he was shaking around, and I looked over and I'm like, what the hell's going on over there? I didn't know. I thought like a raccoon was on the porch trying to do something. So I went over there, and I had my phone with me because I was going to take pictures of it. And all of a sudden, the sunflower seed bag started moving. So I grabbed my pool cue and I started playing around with it. Maybe I should find a way to get the video online and show it to you. Anyway, a mouse fell in and got caught in my sunflower seeds. So sunflower seeds are a good way to catch mice. No, I didn't kill the damn thing. I went out on the porch and I opened up the bag so that there was a hole. And inside of 30 seconds, the mouse, scared as hell, crawled out and crawled into the thing. So I didn't crunk the mouse. But I thought it was weird. I thought it was very interesting. Anyway, outside of catching mice and slurping coffee and drinking things, it's all Python today. I'm halfway through grading your quizzes for Unit 4. Everyone seems to have done very well, so you have no worries there. Later on tonight, I am hopefully going to do the forum posts and read everything you had to say about a logic called Joe. I also tonight am going to get going with your midterm assignments. I'm going to start reading papers, and you'll see when I read the papers, I comment on them in line, and then I save it in a file called Graded. You guys drive me nuts. For future reference, when you hand in a project, put your name on the file, please. I know it's your Dropbox, but I'm basically downloading everything and putting it in one file. So when you name your paper midterm or Python paper or this or that, I don't know whose it is. All right? I'm renaming every single project. Not all of you. Some of you are good and put your name in the name of it. But for future reference, when you send somebody something, put your name in the name of the file. I know who you are. I know what Dropbox I'm in, but I have to still rename it, and it's driving me insane. All right? Don't ever, if you're applying for a grant or you're ever applying for anything, don't ever send anyone called paper.docx. Okay? It's not going to work. All right, enough of my old man complaining. You be good. I will probably hit you with a slew of announcements and a slew of insanity tomorrow. Tomorrow or the next, I will get you the assignment for Unit 5. Keep trudging along. I'm doing Python every day until I get you guys clear. So hopefully Hans tomorrow, while he's at the cave, will find some time and grade the assignments for Unit 4. That way I'll get a full grade book by Monday. I can start sending you Unit 4 grades. I know just yesterday you got Unit 3. But I want to keep chugging along. I don't want to, get behind. I don't want to do stuff. Because you want to enjoy Thanksgiving. And I don't expect you to sit and code all Thanksgiving holiday. Take a little time and do some stuff. But like I said yesterday, time is on our side. I mean, I'm sure we will extend Unit 5. And you'll have extra time. And you'll have time to do your final project. And everything will be good. I got to do that too. A lot of you are sending me proposals. Get me those proposals. If you haven't sent me a proposal yet, you're officially late. So get it to me, all right? It's not going to affect your grade, though, because I'm an old softy. Do all that stuff and get it to me. Because the sooner I approve your proposal, the sooner you can get working on that design document, and the sooner you can get coding and creating something neat, all right? All right, then I'm going to get out of here. You guys be good, and I will talk to you later, all right?